Hello, welcome to this video on integrals demystified. In this video, we try to demystify and solve the given integral. Here, the given integral is secant cubed of x. Often considered a very tricky integral, it involves a few sneak peek and manipulation here and there to ultimately get an answer. But here, let's demystify it and try to make it as clear as possible. Right? Secant cubed x. What's the first thing that hits my mind? It's not simple. A secant cubed, a power 3. Why is it a power of 3? So one thing that hits my mind is I can do a u substitution somewhere and find the function and its derivative inside the bracket. So first thing I do is separate it into secant x and secant squared x dx. Now one thing we need to realize is taking out secant squared x and separating it into tan squared x plus 1 would only put back secant squared. There's nothing new we're doing. So I want to do, integration by parts. Let's say integration by parts. And so you know that if you have a total derivative of a function uv, then it comes out to be v du plus u dv. Then integral v du, because of the relation, comes out to be uv minus integral u dv. How? Look at this. uv is a function of u and v, variables u and v. The total derivative of uv will be v du, a derivative when v is constant, when u is considered constant. And if I apply the integral sign on both sides of the equality sign, d and the integral sign gets annihilated and you have uv. And let's take this to the other side. Now let's look at this integral in this form. Whenever I'm doing an integration by parts, my goal will be to make dv as simple as possible and this integral as simple as possible. When I look at this in the form of v du, finding that if I consider v as secant x, finding the derivative of secant x is simple. Derivative of secant x is nothing but secant x tan x. Right? We know that already. However, finding the derivative of secant squared x, it's not that hard, but it's just extra work. Derivative of secant x will be 2 times secant x into secant x tan x. That will be 2 times secant squared x tan x. It's hard. So let's try that. Let v be equal to secant x, then du must be equal to secant squared x. Wow. Ring a bell? Do you know that if u is tan x, then du becomes a secant squared x dx. The derivative of tan x is secant squared x, so u and du fit miraculously well. So then if I translate this into using the integration by parts formula, I'll do it here. Integral secant cubed x is equal to integral secant x secant squared x will be equal to u into v, where u is tan x and v is secant x tan x minus integral u into dv, where u is tan x and dv is the derivative of secant x. And you know the derivative of secant x tan x. I have secant x tan x. Integral of secant cubed x is secant x tan x minus integral secant x tan squared x. Okay, where are we going now? Again, we can use the relation that secant squared x minus tan squared x equals 1. Very useful relation. If you have it by your fingertips, all your integrals are done. Let's try this relation. This gives us secant x into tan x minus integral secant x into, this becomes 1 plus secant, this becomes secant squared x minus 1, right, dx. This becomes secant x tan x minus integral secant cubed x dx plus integral secant x dx. Wow, okay. So you have secant cubed x both on your LHS and your RHS. We are trying to find this. This is the unknown, right? This is the unknown. We don't know this. Just move this to the right, and you have 2 times integral secant cubed x dx equals secant x tan x plus integral secant x dx. Assuming we already know the integral of secant x, which is quite simple, then this will be secant x tan x plus ln mod of secant x plus tan x. This is the natural logarithm ln plus c. Now that was secant integral of secant 2 times integral of secant cubed x. Finally, we have integral secant cubed x dx is equal to secant x tan x by 2 plus ln by 2 mod of secant x plus tan x plus c dash. This is what we have been looking to solve in the beginning, and we are done. That's it for this video. Thank you.